Hello everyone! Today we're talking about the volume formula for a sphere. We're also going to cover some surface area stuff at the end, so keep an eye out for that. Our objective for today is that students will be able to solve for the volume of a sphere using the volume of a sphere formula. One application of this would be considering how the volume of a sphere impacts our everyday life. So imagine that you're packing for a beach trip and you need to find the volume of a beach ball to compare how many you can fit into your car versus if they were deflated. So do I want to travel with these that are inflated or these that are deflated? In this box, I'd like you to pause this video and write down one other application of finding the volume of a sphere. Awesome. So hopefully you've had a moment to do that. And we are going to move on to our notes. So this first question is just a thinking question. What I would like you to do is list 3 differences between a marble and a beach ball. Go ahead, pause this video, and take a moment to do that. So hopefully you had a minute to compare and contrast a marble and a beach ball. Now you may have talked about the material that they're made out of, you may have talked about their size, right? But what I was really hoping that we would get to here is that a beach ball is hollow and a marble is solid. And the reason that this is important is that technically speaking, the definition of a sphere is a hollow 3D shape that is the shape of a ball. Now this is a really colloquial definition, right? So it's not using specific mathematical language. If I were to define this mathematically, I would talk about rotating a half circle around an axis and how that would create a sphere. But here, I think that this gets the idea across to us. So the difference between a sphere, which is like a beach ball, and a solid sphere is a 3D shape that is not hollow. So this is the equivalent of our marble, right? It's filled in inside. This won't have very much of an implication for us when we're talking about the problems we're going to do today. But when you think about density in the future, that's when these are really going to matter. Let's talk about some examples. So our first example would be, of course, a beach ball for a sphere and a marble for a solid sphere. Some non-examples of spheres. So these are things that are not perfectly round. Okay, so obviously a cube is not a sphere, but also an egg is not a sphere because it's a little bit oblong. So when we're talking about these characteristics, they're really looking for just the really basic characteristic of what we think of when we think of a sphere and a solid sphere. And really all that is hollow and solid. So now that we've talked about some definitions, let's move on to the next page. So here we have 3 objects. We have a hemisphere, which is half of a sphere, right? Hemisphere, hemi, that prefix means half. Then we have a cone, which you guys have seen in the past little bit, and also a cylinder, which we've also talked about previously. So what I'd like you to do in this box is think about how are these 3 things similar? When you look at each of these 3 shapes, what do they all have in common? Take a moment and write that down. Thanks for taking a chance to do that. Now the next section is not mandatory. It is extra credit. So this video will be attached to your Google Classroom assignment, and it is also linked in the notes. So you should be able to click on this link and get to a video that explains the proof of the volume formula that we are about to talk about. So this proof is a little bit complicated, but you guys are totally able to understand it. I believe that every single one of you could watch this video and get a surface level understanding of what's going on. However, I didn't want to take time in this video to explain that. So this is an extra credit question. In this box, you can take notes, whether that's on paper or you can type them. Just take some notes while you're watching the video that include these words: Cavalieri's principle, hemisphere, which remember is a half sphere, and cross-section. And if you include those 3 words in your notes, you'll get a couple extra credit points when you turn this in. So the big punchline of all of this when we're talking about spheres and solid spheres are our formulas. So the formula for the volume of a sphere is volume is equal to 4/3 pi r cubed. And the surface area for a sphere, so how much paint would I need to cover the outside of the sphere? That's actually 4 pi r squared. And remember that r in this case is the radius. So let's try these equations out, and then you'll work on some practice on your own. So our first example here says to find the volume of a sphere with a radius of 4. So we know that in this case, r is equal to 4. So if I want to find the volume here, I'm just going to plug in my equation. So volume is equal to 4/3 pi times 4 cubed. Remember that this cubed means I'm doing 4 times 4 times 4. And if I do 4 times 4 times 4, I get 64. So really what this is it's 4/3 times 64 times pi. Remember that pi is actually 3.14. And if we put 4 divided by 3 into our calculator, we get 1.3 repeating. So then we're just going to multiply these 3 numbers together. 1.33333, just throw a bunch of 3's in there, times 64 times 3.14 for pi. And we get 267.9. And this is the volume for our sphere. Now let's try out the surface area of the sphere. So if I want to find surface area, I know that my formula is 4 pi r squared. It's really important that this one is r squared because we're in 2 dimensions, and this one is r cubed because we're in 3 dimensions, right? Volume is in 3 dimensions, so we're cubing that r. Area is in 2 dimensions, so we're only squaring it. So 4 pi r squared, if I put in my numbers, 4 times pi we know is 3.14, and r squared, r is 4. If I square that 4, I get 16. So I'm doing 4 times 3.14 times 16. If I put that into my calculator and I multiply it, I get 200.96 as my answer for surface area. So those are all of the new skills we're learning today. This was a pretty straightforward lesson. These 2 formulas are the most important things that we went over today. Let's take a look at the practice just so that you know what you're doing. So when you're looking at the level 1 practice, we have given you either the radius or the diameter. Remember that you have to have the radius, and the radius is from the center to the outside, like this. In this case, since it's from the center to the outside, that's the radius. Now in number 2, when it goes the whole way across, that's actually the diameter. So to figure out what the radius is, we divide 12 divided by 2, and we get 6. So that means if our diameter is 12, that means our radius is 6. The same thing can be said for the rest of the questions. In these first 4, you're finding surface area. In the next 4 questions, you're finding volume. And then we have some level 2 questions at the end that ask you to think a little bit more. If you have any questions at all, remember that you can contact your teachers on Google Classroom. You can also come to coach class every afternoon. Good luck!